All right, thank you for joining us today. And in this video, we are going to talk about what? Cartesian product. So we spent time talking about intersection, union, two set, three set, and we were looking at how we can prove some theorems and stuff. Now we are shifting our mind to Cartesian product, and we are going to look at how we can also work with what? Cartesian product. Let's jump right in. So what is a Cartesian product, right? What is a Cartesian product? So we are trying to say that the Cartesian product of two sets is the set of all ordered pair. So that is the word, ordered pairs. So we want to, it should go in ordered form, right? So ordered pair formed by taking an element from the first set and pairing it with an element from the second set. So let me give you some short definition here. So if A and B are two sets, right, are two sets, what will be their Cartesian plane? Then A cross B, that is the Cartesian, will be equal to AB such that A belongs to A, small a belongs to A, and small b belongs to big A. So this will be the Cartesian definition, right? So what we are saying is, with this, what we are trying to say is, this means that for every element in A, we pair it with every element in B, forming ordered pair. For example, let's look at, if I have A to be equal to, let's say, AB, right? And then I have B to be equal to, let's say, ABC. Then what is A cross B? So I'm going to pick all the elements in A and use it to pair all elements in this, right? So let me just do this one. Let me change this one to 1 and 2, right? So that we can relate it very well. So this is 1 going to pair with A, pair with B, pair with C. When I'm done, I take 2 to pair with A, B, and C. So I'm going to have something like 1 and A, 1 and B, 1 and C. Nice, right? So when I'm done, the next one will be 2 and A, 2 and B, 2 and C. So this is what I'm going to have. So 1 and A, 1 and B, 1 and C. Then since this one we have used it to pair all elements in B, we need to move to the next element in A. We use all of them to pair it. So let's assume we have 3 here. When you finish, we need to use 3 to pair all the elements in what? In B. So that is the idea of what? The Cartesian plane. Right? Now let's talk about some characteristics of Cartesian plane. Like, let's try and talk about some of the things that we can think of doing when we are talking about, characteristics of a Cartesian plane, right? So we need to use some of them so that when we are doing some of the proofs, we can also use them as well. So let's look at the first one that we can talk about. So characteristics of Cartesian plane. So let's talk about characteristics. So the first one that we are going to talk about is, we are going to assume that we have two elements, let's say A and B, and these two elements, we are going to assume that these two elements are the same, right? These two elements are the same. I mean, like, when we want to cross, let's say, two elements, let's say S cross S cross T, right? Now we are going to say that this is the same if and only if, let's assume that we have an element X and T. This is the same as A and B. So that this one will imply that S is equal to A and T is equal to B, right? So if we have two elements of the product, like two elements on this product, right? And we are saying that this is the same, they are equal, if and only if they are what? Identical. So this is the same as this and this is the same as this. Then we can say that they are the same, right? So that is one property that we need to look at. Another one is like if we assume that X is an empty, or so X is empty or T is empty, then what can we say? X cross T was also going to be empty. We don't have anything there. So even if one is not empty and the other one is empty, we are going to get empty because we cannot pair them because one of them is what? Empty. Is that right? And then another thing that we need to look at it is it because this one goes with ordered pair, then S cross T is never the same as S cross T cross S, right? Because if I have let's say S and T, which belongs to let's say S cross T, then I have TX belonging to T cross S, then we can see that they are not the same, because the idea is that we are looking at the ordered pair, right? We are looking at the ordered pair. Ordered pair. Oops, this one should be X and T, right? So if this element belongs to this and the same element also belongs to this, you can see the relationship, right? So these are not the same. These are not the same. Another one that we can talk about is, if we have identical values, right? We have the same values. Like assuming I have A cross A cross A, this one can be written as AQ. So that's one thing that we can also learn from this side, right?